Hey guys, back to finish week 15, chapter 12 solutions. Let's do the math. My least favorite part, but part that's going to show up in the homework. So looking at what we've done so far in math in our previous chapter that we're now piggybacking on, 1 mole is Avogadro's number. Atoms, molecules, formula units, doesn't matter. I'm just going to use atoms, that's the most common type. You'll see that a few times in this homework, not much. One that you'll see a lot in this chapter is 1 mole is grams on the periodic table, PT periodic table. Going to use that one a lot. We also know that if you want moles to moles, whether you're converting this to that, reacted to product, ingredient to cake kind of idea, what we typically use there is coefficients. That's when you have balanced equations. There's a few of those in this chapter. They're related to acid-base neutralizations with titrations, much like our lab 23. You can also look for subscripts, and that's going to be with a chemical formula. And probably not going to use that one much at all. I think there's 2 questions that use it, talking about ions of sodium and nitrate or something like that. It's not going to be useful. Most of what you're going to use is those coefficients with the balanced equation with acids and bases in this chapter. What's brand new is capital M. In a sense, this is capital MM, molar mass. We just didn't really use those kinds of designations. But capital M is something that's been on every bottle in lab throughout the entire semester. You can go back and look at videos. They're on every bottle that I've made and used. Capital M is a concentration. Tells us how much is mixed with water in a solution. So hence the name of this chapter. So capital M, importantly though, is moles of the solute over liters of the solution. So typically how we use it is we can use capital M for the moles if we assume 1 liter. So when they give you capital M in a problem, just plug it in and you have a conversion to do everything we've done in the last chapter. Oftentimes we can cheat and say moles over 1,000 milliliters and save ourselves the time, again put capital M here, save ourselves the time of doing that metric 1 liter to 1,000 milliliters conversion to save face on what we normally do with those 3 conversions, moles on top, top and bottom, to make it look just like our last chapter. The only other math in this chapter is piece divided by the whole times 100. Because let's face it, in reality, for those that are in the allied health kind of track, which is a lot of you, are you really going to carry a periodic table around in your pocket? The answer is definitely no. So will you ever use any of these moles? Definitely not. Will you use percentages on IV bags? Definitely you will. So if you run out of IVs, whether it's electrolytes or some kind of glucose solution, you might have to make a percentage solution in some of those disaster situations. Most of the time you're just going to grab one off the shelf and run with it. But either way, the math is going to tell us how much is mixed inside. So when we do this, there's several kinds of problems to deal with. There's some where we find capital M. So if we're going to find capital M, how do we do that? This is going to be most similar to your homework in that matching section. It's going to be the first matching section, 55 through 58. They're going to give moles, and then they're going to give some volume. Well, lucky for us, capital M is moles over liter. So if they give us liters, we just divide moles and we're done. If they give us moles and they give us milliliters, that's a problem because the definition is per 1,000 milliliters, and if you don't have 1,000 milliliters, it can't be the problem at all. So if they give you moles and milliliters, you're going to have to do a conversion where you're going to put your number in here that's given. So this is given, just like this would be given, and this is capital M itself, or at least the moles that are given. in the problem to find capital M. Milliliters here, liters here, there's 1,000 for every 1 liter. Those cancel, so now we'll get moles over liters. So sometimes it takes 2 steps if you're in the wrong unit for capital M, but oftentimes you're not. Oftentimes they give you liters straight away and it's just division and you're done, which is nice. Let's say though that if they have grams and they want you to go to capital M. If that's the case, they're also going to have to give you volume. Let's just say we have 10 grams of sodium chloride and we put it into 100 milliliters of water. What kind of solution does that make? Well, much like in our chapter before, it's just conversion rate. So if you have 10 grams, we need moles. So 10 grams of sodium chloride, we need to go and get rid of grams sodium chloride and go to moles of sodium chloride. So then we have this top number. 1 mole, this is Na plus Cl, so that's about 23 plus 35.5, so it's about 58.5. Close enough off the top of my head. So get 10 divided by 58.5. So 0.171. And in reality, they give you this number in a lot of the homework. But if they don't, this is how to find it. So now we know that capital M is 0.171 moles. Check. Top number. Do they give us liters? No, they gave us milliliters. So we're going to have to use this setup where we take our milliliters, which in this case was 100, and convert it to liters. So there's 1,000 milliliters in 1 liter of solution. The water will be the volume of our solution with that negligible amount of sodium chloride in it. Cancel. And now we get 0.171 divided by 100 times it by 1,000. Capital M is, could have done that one in my head, 1.71. So that's how you do those kinds of problems, finding capital M. Just remember, if you have liters, you didn't have to do this extra step. Another kind of problem would be if you have capital M, how do you get to, again, this would have been more than likely 100 milliliters of solution, not water. That would be an important feature because we don't want moles divided by volume of solvent, we want volume of solution. So remember that's important. But if we want to know grams or milliliters given a capital M, that's a little bit different kind of problem, but it's using the same kind of sequence, just not this number divided by number issue. It's going to be more traditional to what we saw before. So if we want to go from grams to milliliters, or milliliters to grams, which would be the reverse, take grams and cancel grams. Go to moles. In 1 mole, you can use the periodic table here. If you have moles, you can go to liters or milliliters. Let's just say liters, because that's the case for, say, 62 through 64 in their homework. In 1 liter, you can use capital M here. So let's say that we have 10 grams of sodium chloride, and the bottle is 1.5 capital M. So if we have 10 grams of solute, how much volume of our solution do we need to make this solution that concentration specifically? So we take our 10 grams of sodium chloride, we put in sodium chloride here. We have its mass from above, which was that 58.5 kind of number, Na plus Cl. NaCl, the concentration we need is 1.5, so this is where we use capital M and plug it in. We're using 1 liter. So here we take 10 grams divided by 58.5, which gives us the moles. Divide that by the 1.5 concentration we want to create in the bottle. You get 0.11396, so liters. If you move that back 3 spaces, that would be milliliters, so that's about 114 milliliters. So that's saying that if you weigh on the balance 10 grams of sodium chloride, so put your wax paper down, put on 10 grams. They're saying take that 10 grams, put it into a container. So here's your 10 grams at the bottom. They're going to say add 114 mils of water roughly. So that when you fill this up to 114 perfectly, it won't be quite that amount because you have about 10 grams of volume in there too, but whatever that total 114 volume is, this would be labeled 1.5 capital N. So that's how I make just about every solution throughout the semester. I have a bottle in the stockroom. I know the concentration that the experiment calls for. I just need to calculate what volume to put it in to have the right strength, have the right concentration. The opposite would be true if you have milliliters of solution and you want to go backwards. Just take this, flip this over, and then you'll get your reverse of that same process. So milliliters will cancel down, moles will cancel down, grams will be up top, grams will be your answer. So the same thing works, but in reverse for say 59 through 61. Lastly, what we need to show is percentages. I talked about finding capital M, talked about milliliters to grams or grams to milliliters. There's another one that's worth talking about that uses moles. It's probably the last one that I'll mention, and that's dilution. So M1V1 equals M2V2 is dilution. So sometimes we have strong acids that we need to make into weak acids for lab. Since acids are already in a solution, there's really no way to measure out grams, at least efficiently. So let's say we have 12 molar hydrochloric acid. We want to know the volume required to make 1 molar hydrochloric acid, and we only need 1 liter. So in order to calculate this, we just need to solve for V, just like algebra. So to get V by itself, you divide by 12, capital M on both sides. This side will reduce to 1, so V is left. Molarity cancels, so we really just have 1/12. So 1 divided by 12 gets you 0.083 liters. And this tells us how much volume of the strong stuff we need to make the weak stuff. So it's basically saying, in this case, move it back 3 spaces, this is 83 milliliters. So they're saying if you take 83 milliliters of 12 molar hydrochloric acid, so put that into a graduated cylinder, measure it out to 83 milliliters, you're going to put that into a larger flask that measures exactly 1 liter. You're going to put in your 83 milliliters, which isn't much because it's super strong. And then what do you think's missing? Well, 1,000 minus 83 says we're going to need about 917 milliliters of water to dilute that strong stuff down. Shake it up. This is going to be 1 capital N when you're done. And that's the label we would put on it as we would use it in class in some kind of little bottle. So this is the other kind of conversion that we do, and I think you use dilution once or twice in the homework. It's also used once on the final exam in its traditional format. So that's the other way to make a solution. The last idea is to do percentages. Definitely the easiest type. Percentages is piece divided by the whole times 100 equals percentage. So if you have 25 milliliters of ethanol and you put it into 100 milliliters of solution, what is the percentage? Well, we said earlier, and this was in the previous lecture, you can take piece, 25 mils, which is the solute, so divide it by the whole, which is 100 mils, times it by 100, then you get 25%. 25% alcohol would be 50 proof. And that's quite a bit. One thing that they do though, and you gotta watch out for, is what if they said 25 milliliters of ethanol and 100 milliliters of water. Now they gave you piece and other piece. So you gotta be careful, because here they gave you piece and here they gave you whole. Solution has the alcohol and the water together, and here they're separate. So if that happens, and it does happen in the homework a couple times just to keep you honest, take 25, divide it by 25 plus 100, because together they make the whole. Times that by 100, so you get 25 divided by 125 times 100, and you get only 20%. So this is 20% alcohol or ethanol, just like this was out. So watch out. If water's there, you're gonna have to divide by both. If solution's there, you're fine. And you should be fine in the 65 through 67 of your homework, because they do give you solution. But a couple times in the homework they won't. So watch out for capital M. Know that capital M is just a conversion. Capital M conversions are very common. Remember, in any capital M conversion, you're using capital M as a number in your parentheses to convert. Your moles are going to cancel just like your grams are going to cancel, just like our other chapters. But now what we're using is a variety of where moles and liters mix, or moles and milliliters, depending on the situation. So it's very important to remember that capital M is really all that's new in this chapter mathematically. So we'll see you next time.